you would have pretty much unlimited access to energy. Geothermal is available anywhere on the planet. If we would get down to depths of 10 kilometers, pretty much geothermal would generate nearly on par energy as coal.
Max Werner is a deep tech entrepreneur driving the future of energy and security. He leads Hades Mining, focused on geothermal power and critical minerals, and previously founded WeCorp in drones and Adarga in AI for defense.
That would be incredibly powerful democratic tool of everywhere on Earth enabling secure power access. It's all about making pretty much the access technology more affordable. We are probably in the poor position in the world at the moment. The only component which is currently missing, and it's the most important component unfortunately, is...
Welcome, Max. What made you look at geothermal for the first time and say this could be an actual game changer?
Well, first of all, geothermal is available anywhere on the planet. It's pretty much like the only energy source where you don't need fuel to burn it. It ultimately uses the heat of the earth. And the only thing you need to achieve is ultimately going deep down enough so you can access that heat. So that's very exciting. It's a very democratic way of energy, I would say.
Mm-hmm. And if this technology succeed, what would become possible?
Well, if we would get down to depths of 10 kilometers, pretty much geothermal would generate nearly on par energy as coal at 7 to 10 kilometers deep, dependent on what geology you are. It pretty much has the power efficiency of coal, and that would be insane, right? You just drill a hole, actually two, and with those two holes, you pretty much put water inside, the water heats it up through the earth, creates steam, and that steam creates power. So that would be incredibly powerful democratic tool of everywhere on Earth enabling secure power access. And that's something we deeply believe in here at Hades.
And I'm not a big expert on the technology, so you explained a little bit how this works, but maybe you could walk us through exactly, maybe the complexities, what are the difficulties at the moment, and how would this work in an ideal stage then?
Yeah, like again saying there are two holes 7 to 10 kilometers. That sounds very easy, but in reality, that's incredibly complex. The deepest hole on the planet, I think, was in Siberia, which was 11.2 kilometers deep. Took, I think, 30 to 20 years to drill. Cost more than by now's money is something like 500 million to do these two deep holes. So insanely expensive, very, very complex, and really hard to do with the modern technology. The deepest hole in Europe actually is close to Munich or in the south of Germany, which is 9.3 kilometers deep. And this as well took multiple years to drill and was pretty much a prestigious scientific project. So this is by no means with the current technology something that you can simply do as an operational or as a company, or even the energy you would produce with it would not be able to break even because it's way too expensive. And so it's all about making pretty much the access technology more affordable in order to unlock the actual benefits of what you are unlocking down there.
Okay.
And that's very similar to the reusable rockets in that sense. It's just the other way around, right? Like it's just easier and more affordable access to the underworld. This is also where we have our name from with Hades.
Before we turn into your company, maybe let's look into the vision a little bit more. You said it's an basically incredible new source of energy. Could you draw us a picture of how this would look like at maybe full potential? Let's imagine in 10 years, your company is successful, other companies are successful. We have this as a really usable power source worldwide. What would be the potential here?
Again, if you could pretty much bring the drilling costs down and you could reliably go in the area of like 10 kilometers or even beyond, you would have pretty much unlimited access to energy. That's as simple as it is. Because again, as soon as you pretty much make this economic equation at a break-even level that you can ultimately afford to drill that deep, then the whole project is pretty much something that everyone can fund because, of course, there is an investment case for anyone. So money would be available. It's as a resource, it's not scarce. Again, you can do it absolutely everywhere. So that really is the best case scenario. It's a reprintable energy case that doesn't require resources and is, of course, also very CO2 efficient in every way. Of course, the drills have some level of energy that they need as well. But in general, it's very, very energy efficient and doesn't create any carbon dioxide or anything else.
And this is technology that can be used everywhere in the world. And compared to, let's say, when we look at solar versus coal is centralized, solar is decentralized. How would geothermal look like?
So geothermal just needs to drill, right? Like every of the overground infrastructure, as I said, is just a gas turbine pretty much with which uses the steam to generate electricity, and everything else is comparably low tech, like not saying super easy. Again, in that depth, the pressure is something to take a look at, but generally, this is something that every country has access now and is easily available through other industries as well. So all of the components of making geothermal scalable are already there. The only component which is currently missing, and it's the most important component, unfortunately, is the access to that kind of level at the cost and unit economics that make geothermal attractive.
And that brings us directly to Hades and your company that you now are building. Can you maybe walk us through, what inspired you? What was the unique insight? What makes you special? What shapes your company in a different way compared to the other approaches to geothermal right now?
Well, we are very mission-driven, I would say, and coming from a military background, I'm very passionate about Europe and the continent where we come from. And when I heard in 2020 that the European Union legislated the so-called Critical Mineral Act, which was meant to increase domestic production of critical minerals within Europe. That really was the first warning sign for me, because again, in the act, if you actually read it, the target is to get up to over 10% domestic production up to 2030. That was legislated in 2020. And when we did some research on the macroeconomics of critical minerals, we actually found out that in 2020, production of critical minerals in Europe was below 3%, which puts us easiest at the lowest spot in the world. And that's something that really made me worried, because again, of course, pandemics like Corona very much disrupted supply chains, right? It doesn't need to be a war or anything that can ultimately cut off a lot of supply chain access on a global scale. And if this is something that is needed for industry like healthcare, if it's needed for the defense industry, for energy production, all of those essential industries that pretty much enable our daily life and society, then that is very dangerous. And again, 2 to 3% is too low. The second lowest after Europe is India with 23. So the gap is insane. Yeah, and I get it. We decided back in the day for globalization to go all in and benefited massively from it. But again, the times now have taught us a few things, and I think it's now time to correct that as fast as possible. And we do need to acknowledge the European Union has identified that as early as 2020. And if we go on the energy side, it's not looking better. We are producing 42% of the energy domestically. That doesn't include the materials, the raw materials that are needed to produce that material. So again, it wouldn't include oil and gas. It wouldn't include all the fluids that make it work, which are, of course, essential to actually generate the energy. If you would calculate those in, we are at 18%, which also firmly puts us at one of the lowest spots on the energy production.
And from a technological perspective? I mean, you're trying to solve the drilling problem, essentially, right?
That is correct. I mean, we have analyzed pretty much the entire technology stack of the mining industry and resource extraction in general in Europe. And we very quickly identified that the highest cost driver in European critical mineral and resource extraction projects by far, we speak about 50 to 70% of the total capex is drilling costs. It's pure drilling costs. And if you actually then look into the specific drilling costs, it is always the core technology of the drill that creates these kind of costs, because it has the biggest impact on the costs by just taking very, very long. And especially if you go deeper and deeper and deeper, the rock becomes harder. Usually you have pressure, you have water coming in and all of this stuff, and the drill slows down. And this speed is a big problem, because the longer it takes, the more the crews need to be up there, the environment need to be leased, all the infrastructure and assets are very cost intensive, and it's all a lever that is related to the time it takes to actually get there. So the speed, the so-called rate of penetration, is absolutely everything in terms of drilling costs.
And Hades uniquely combines geothermal and critical minerals. It's both in your mission, and also you think that with the technology that you have, you can actually solve both of these problems at the same time. So how does this work, and how do these two worlds intersect?
So We believe that the impact of developing a new drill is so big that it actually has an impact on all of the resource extraction sectors, like be it critical minerals or geothermal, as in extracting the energy out of geothermal heat. So that is, the drilling is the lowest common denominator of all of these industries. And the drill that we have started developing and where we are making very rapid progress as well is so generationally different and better than what mechanical drill is doing, that is really changing the unit economics for every single one of these sectors. So we do believe that with this key technology, we can have an enormous impact on all of those industries, making critical minerals more affordable, but also making geothermal affordable. And then there is affordable, and then there is access as well. Because again, in that kind of depth, if you go deeper than 2-3 kilometers, again, there's another challenges for the normal mechanical drill. A lot of them our drill is solving as well.
Could you walk us maybe a little bit through your technology and what makes it special, for a non-technical audience maybe?
Yes, we use a fiber laser pretty much. So ultimately, we use the heat of the laser, a very, very high concentration of pretty much photonic energy to burn and melt and disintegrate the stone that we go through. And this is revolutionary in two ways. The first one is because you need to imagine the mechanical drill is like your drill at home, right? Like where you drill a hole in the wall, you are in direct contact, you have a harder material, which is the drill, and it carves away your hole. And that is a bit of an issue because it's in direct contact with the material, which means also like the drill at home, sometimes it goes to the path of least resistance, right? Because if it finds something that is not that hard to go through physically, of course, the force in direct contact will always guide you a little bit in the direction of where it's the path of least resistance. And that is a big issue in actual drilling because you lose precision. You can imagine like there are very, very, very different kinds of stones down there and underground. And if you send a mechanical drill through, it always has a way of going to the path of least resistance. And this is a 40-ton machine, right? To steer it is possible. There is so-called directional drilling, but it's very hard. It's not precision. Because again, the ultimate physical principle is always this direct contact and this massive physical force. And so the precision lack is one of the biggest issues. And then the second one is ultimately the wear and tear of the material that you are in direct contact with. So a modern mechanical drill has around 36 artificial diamonds at the top. Those diamonds are carving away the material, and they of course use down. And the harder the material you go through, the faster ultimately those diamonds wear down. And that creates costs. It creates costs as slowdown. Actually, if you go through hard rock, drilling is incredibly slow. If you have enormous costs by changing the head all the time, even every few hundred meters, if you go over multiple kilometers. And then changing the head in drilling is not like your CNC machine where you just open the door and change the head. Like this means you need to, over days, take kilometers of mechanical connections that weigh tons of force out, switch the head, then put all of that in again, ultimately having delay of 3 to 4 days all the time. So all of this is always an equation of the speed that you have to get through. And the mechanical drill really has some issues with that, yeah.
So that's, I think, very clear. So the technology that you're using is a breakthrough technology. It will change the game. So when we zoom out a little bit, again, geographically speaking, you outlined a little bit that Europe is your strategic priority in a way, but are there regions in the world that are, in principle, because of the geographical setup, more attractive for geothermal than others, or is everything the same pretty much?
So, of course, pretty much the better geology you have, ultimately, for example, Iceland is the perfect spot for geothermal energy because the geological heat up there is much closer to the surface, which means if you there drill 1 kilometer, this is the equivalent of drilling here 3 to 4 kilometers. And 4 kilometers is this magic sweet spot when it comes to geothermal because at 4 kilometers of depth in Germany, at least, and most of Europe, you can actually have enough heat difference to generate power. And everything before is only heat. So the heat is not enough to really put it into steam and actually generate electricity. So the heat difference is what it's all about. And again, in Iceland, you don't have that issue because again, at 1 kilometer, you already have that heat difference. So there, it's very affordable and geothermal is a much bigger mix of the energy mix. But again, the drilling is not really hard there either, because you do only need to drill 1 kilometer. This is not the case here. And in the vast majority, I think like 99.9% of Earth, this is not the case. In the rest of the world, again, 4 kilometer roughly is the sweet spot where it's all about.
And if I can ask you to make a prediction, which I know is always hard, when do you think we will get there to have geothermal energy as like a meaningful share of the energy mix?
Be honest with you, I think all the geothermal projects that we are currently seeing are in the end research projects. I have not seen a single geothermal project in Europe or the US that is actually commercially attractive, that would attract normal investors. They are hugely government funded. They are pretty much research projects. They are not returning on their investment, again, because the drilling costs are not justifying the energy production, even at 4 kilometers. And so it's still worthy to do that R&D, and I acknowledge that, but I think it's really important that we first really solve the fundamental problem that makes the unit economics not work. And again, this always comes back to the drilling. And for the drilling to update that it actually makes the unit economics at 4 kilometers of depth more attractive, I think we are at Hades. We are probably in the pole position in the world at the moment, and we will be able to drill at 4 kilometers in just about 5 years.
Okay, that's fantastic news. And maybe one question about the technology, because it's something that seems familiar to many, but it's really unfamiliar. Is there like a myth about geothermal that you want to kill now once and for all?
Yeah, again, that it's very, very easy to do and free energy and all of it. Again, the big issue of geothermal is the unit economics that don't work. Like, this is indeed the myth that I want to talk about. Geothermal, as it is now with a mechanical drill, is not an affordable or in any way working power form that actually could justify the investment for it.
Do you think we will see fusion energy at scale first or geothermal?
Geothermal for sure, guaranteed.
Okay. And what kind of political support do you need to truly succeed in this?
Well, the good thing is, I think Germany is really at the absolute forefront when it comes to that topic, because we legislated just recently, I think on the 4th of December, actually, the parliament approved the Geothermal Acceleration Act, which is pretty much shortening the licensing procedure to set up new geothermal projects. So that is a big win, and I absolutely adore it. And I think it's sometimes really good to see if politics do work, and this really is a sign of it. I personally very much think that this same law should be multiplied for critical mineral projects as well, because ultimately it's the same type of project and they have the same critical need geopolitically at the moment. Nevertheless, again, I'm very happy that geothermal already has that Acceleration Act, and it pretty much cuts the time from 4 to 5 years approval procedure to around about 2 if everything goes well, and I think that's a huge win. So now it's all about getting the access technology right, making the whole thing profitable, and then we can really put a huge pipeline of new geothermal projects in. The vision here is pretty much every small and medium term, no, not small, but from medium term level companies that are pretty much having hardware production that have some energy needs. They could use geothermal by themselves to be energy independent. Councils can pretty much lower their electricity price with geothermal pretty easily. So this is really something that we want to vastly scale as well. And this is something, while next year Hades will launch a new initiative that will dramatically push new projects to go into the pipeline. This is secret still now, but we are very much involved in actually developing a lot of these projects as well.
And you mentioned critical minerals. This is part of your mission as a business as well. Could you walk us through, how your technology will change this game? Because at the moment it's largely concentrated in China, the extraction. So how would this technology make critical mineral extraction around the world easier, maybe, or cleaner?
I think there I do also need to pretty much talk about a bit of a myth. When we talk about mining, and especially Hades, when we talk about mining, we are not speaking about these huge open pit mines, right? Like, we know them, of course, from the Ruhr Valley, and that's very scary, and I hate that as well. Like, this is pretty much the most profitable form of mining, no doubt, because it's very easy to do. You just carve away pretty much huge material, but it's very, very waste inefficient ultimately. 98% of the material that you remove pretty much is not being used or only for construction or some lower tier applications. But of course, the environment is destroyed. It's absolutely devastating for the society. And you need to move villages and all of this stuff. So that is not the way that we see mining. Mining now, with a technology angle to it, has evolved dramatically. And this modern mining is called pretty much surgical mining, where you are injecting drills at the site where you are thinking, or you actually have already found some critical minerals, and then you are injecting strategically into the ground some chemicals that pretty much dissolve the material, and the material is then in liquid form, and then similar to oil and gas, you can just suck those materials through a pipe upwards. This is called ISR mining, in situ recovery, and this is pretty much the most up-to-date version of mining that exists, and we do that in Germany. There's a very big lithium company that actually does this process with lithium already. But again, there is a vast majority of other critical minerals that can also be mined in that way. Still, as we just discussed, of course, this requires drilling again. This is the access technology. And so even in this field, the biggest cost driver is again the drilling costs. And our drill will make that access once again much more affordable and will also go deeper precisely. And precision is here really important because critical minerals are, you don't have them like in a big pocket that you easily just go in. You actually need to point in them very precisely. So your drill needs to be able to be very precise. And once again, that is the fundamental difference between a mechanical drill and our laser drill. The laser destroys the material before it goes through. That's the big difference, right? A mechanical drill destroys it while it's going through. And because of that, it is pretty much deflected all the time. And here we create the hole first and then we go through.
Yeah. I think this is fascinating because I think many people don't realize how many critical minerals reserves actually exist in Europe.
A lot.
And how much potential there is actually.
We have just the identified resources. So that's the one where already, so just maybe for everyone to explain the process, like in mining, the process is exploration, extraction, and recovery. That's the three phases that you have. Exploration means you speak with some geologists. They tell you roughly where the material is thought that is a high concentration of it. Then you do drills, and those drills are recovering pretty much so-called core samples, where you ultimately material from down there if there's actually that material in this. And you do 3 to 4 of these samples, and then you have a very good estimate of that material actually being there. And if that is good enough, you move to extraction, and then you ultimately take it out in the method that you have chosen. And then recovery is indeed to take everything back so it actually looks like it was before. And as you can imagine, all of that is very difficult for a normal open pit mine where you just remove all of that material. Also very, very problematic for underground mining, where you build these huge tunnels. And to be fair, underground mining is the most expensive way of mining in the world because you do need to build infrastructure. So it's not a scalable way of actually getting critical mineral supplies up, especially not in Europe, where tunnel building and everything is insanely expensive. This is only being used in other parts of the world because the standards are much lower, and these tunnels are pretty much created with normal drills as well. So this is really only scalable solution for large-scale production of mining in Europe is with the drill.
Now let's move to your founder's journey for a minute, because it's also super fascinating. You basically moved from drones to AI and now to geothermal and mining. Can you give us maybe some advice, or can you give new founders some advice what they should focus on when they start something on their own?
Well, to be fair, I think it's a high level of pain tolerance. I think is really, really something that is important for that journey. I think also something that I see a lot of founders struggle with is looking at markets and really understanding your competitive field, your advantage in the market. Sometimes people just think of a product and then want to sell it and make a business out of that. And they don't consider ultimately how markets work and the competition. So really focus on markets first, identify your gaps. And if you do not have a gap, your product, of course, needs to have a huge competitive advantage to justify the competition. So most founders take that way too easy. And that's something that do not just simply found something where you know you can't compete with them. And if so, you really need to have a good reason why you can compete with them. And that's really something I would focus on, and I have always focused on as well. My first product was the world's first close quarter combat drone, so a small drone that can ultimately work in special forces applications, and that didn't exist at the time. We did this from 2017 to 2019, and we actually won a NATO competition with that drone as well, as the only company that ever had that capability. Like even the US didn't have that technology. So that really was something that kept me always on my edge when it comes to looking for competitive advantages, segments in the market where there is some weakness that can be exploited. And the same here with Europe, right? Why are we starting in Europe? The approval procedures are way longer, but you also do not have a lot of competition. In Europe, mining is pretty much dead. Like most of the large and junior miners are very underfunded, and they have no competitive advantage to actually do what they do. Now we come with all of this force of funding and new technology, and believe that we can ultimately take a spot in that market.
You talked about pain tolerance, and this is something that I actually heard from many founders already. Is there some advice? Is this something that you either have or have not, or is this something that you can develop?
It's a difficult part, I'll be honest with you, Philip. So ultimately, founder journey is something that can hit very hard. You have the highs, no doubt, but you also have very, very lows. And the very deep lows, they can be very personal. Ultimately, it's a lot of work, especially if you are a lone founder. I was with my first startup, I was a lone founder. Now I have two exceptional co-founders for that very reason. Lone founding is okay, it's very good, but it also comes at a huge downside of ultimately pretty much having no time for you personally anymore. You can, of course, but it comes at a huge sacrifice of your business not being able to thrive at that moment. And that could be a critical disadvantage. So yeah, I think pain tolerance is something that is absolutely needed for every founder. Of course, you can be lucky, but even the lucky ones will get to a moment where pain tolerance is important. When it comes to money, of course, it's a dirty game. So a lot of tricks will be tried. And for that, you need high tolerance, pain tolerance, yeah.
And you built in many different industries. You mentioned drones. What's the one lesson that maybe has proven true across all these different industries?
That's unfair now because it's pretty much like a repetition. But again, the one thing that is overall is, again, that the markets and the competitive situation is really the most important thing. Of course, I can absolutely also iterate that in order to get good teams now, especially technical teams, most of the technical talent now is also in a very competitive situation on the labor market, pretty much. Most of them have now a very good understanding if startups have a chance of actually being good or not. So if you actually do not make your homework on the competitives and the market dynamics, then you also are unlikely to attract good technical talent. And that's something you see sometimes at the early stage founders, right? And they come with a team that is not good yet. That is already a critical sign, right? Because again, everyone knows that good technical talent now also has a good understanding of how the startup market and funding and everything works. And they simply do not come if you are not having some good ideas and strategies as well. And so, yeah, that's something to consider in the total package, I would say.
And now we see many founders actually going into this deep tech segment in which you've always worked. What advice would you give them that is specific to deep tech?
Longer times. I think the thing that makes it so special is ultimately in software, you have this nice curve pretty much that ticks up from day one pretty much because your product is ready even in a prototype way earlier available and you can share it with customers. So you could see the uptick of customer demand very much in revenue. In hardware, that's rarely the case, very, very rarely. Like usually in hardware, you have dead flat for a few years. And once you actually launch some version of the product, you of course have some risks that it doesn't work. But if it works, then you have a huge uptick at a later point that usually comes even higher than the software company. So that's very attractive. But the time it takes to actually get there is very painful because of course you get enormous investor pressure. And the investors that you look in to work with is even more important because if you have an investor who has no experience with hardware, who doesn't know this uptick, even if he says he has, but he doesn't, over the journey of 7 years, the investors will get so nervous, they will pressure you to do pivots and all of this other stuff that ultimately deflects you from your good journey. And that's something that will just kill good businesses. So really make sure that you have some proper hardware investors who have a portfolio of companies that have been successful in deep tech that really really gives you a huge advantage. Just do not go with a simple software investor. They just need to qualify themselves to actually be in that area, because the investor-founder dynamic is always something that is also not to be underestimated.
And when you look back on your journey up to this point, what part of it, through all the different technologies, feels most meaningful to you?
I think the moment where I really was incredibly proud, especially of my team at the time, was when we won that NATO competition. And that was really a meaningful moment. We could save a lot of lives with that technology, although it was lethal ultimately, but the application ultimately reduced the amount of lethality that needs to be deployed. And that was something my team did there, which I was incredibly proud of. Just seeing pretty much these huge military organizations moving rather fast, actually. Because it was really a solution that didn't exist at the time and in that quality. So that really made me very, very proud, yeah. Especially with a military background, because again, some of my comrades have been to Afghanistan at the time, and Afghanistan had this very specific issue very, very much. And so seeing that product, solving that issue, and going into service in the UK at least was something I was very proud of.
Hi, everybody. I want to invite you to connect even deeper with me and the What's Next community and stay updated on the latest trends. If this sounds interesting to you, please join our mailing list. Go to philippmeissner.com/whatsnext to join. Max, we like to end this show on a positive note, so we ask all guests this question, which is, what makes you optimistic about the future?
I believe in Europe, and I think even with the current geopolitical situation, that is also a huge chance to re-identify ourselves, get our back on the core values of pretty much building new industries, being innovative, and ultimately thriving for the values that we represent. That's something that makes me hopeful that the European spirit won't go down.
Max, thank you very much for joining us today on What's Next and for showing us how new technologies can actually produce scalable new energy sources and what this also means for sovereignty for Europe and beyond. Thank you very much.
Really appreciate it, Philip. Thanks so much for having me.